Today we are starting class 12 mathematics. We will start with calculus. Under calculus we are going to deal with 9 chapters. First is the function, second is the ITF, third is the limits. In chapter number 3 we are going to study limits and then continuity and differentiability. Chapter number 4, method of differentiation. Chapter number 5, application of derivatives. 6th, integrals, indefinite integrals, and number 7, definite integrals. First we are going to study indefinite integrals, then definite integrals. Indefinite is this. Definite means you are going to have from 0 to 3 or 0 to pi. Some range. We are going to have some n. And next is area under curves. Next is differential equation. So let's begin with function. Before starting function, let us clear some basics of calculus that we have studied in class 11, 9, 10, 11. First is number system. Let's begin with number system. Here in number system, in hierarchy, the biggest is the complex number. Complex number is divided into, it consists of real number and imaginary numbers. In calculus, we are going to deal with only real numbers. Real number is represented by R with double stroke. Here, see here it's double stroke. Real number is consists of rational and irrationals. Rational and irrationals. And rational number consists of integers and non-integers. Integers are further subdivided into negative integers, 0, and positive integers. If you combine 0 and positive integers, we get whole number. This positive integer is nothing but natural number, also known as counting number. Counting number is nothing but natural numbers. Okay, here is the diagram. You can note it down. Real number, rational number, integers, whole. If you add rational union irrational, irrational is divided by q prime. Rational is represented by q. Q union q prime equal to real. Wait 1 second. Something is okay, there was some technical issue. Let's start. First is the natural numbers. Natural number is denoted by n, capital N, and natural number is equal to 1, 2, 3 up to infinity, positive infinity. This is natural numbers. In number lines we can represent like this. Here it begins with 1, 2, 3, 4 and dot 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 up to infinity. Whole number. Next is whole number. Its whole number is represented by W equal to, it start with 0, 1, 2, 3 and so on. In it start with number line, start with 0, 1, 2, 3 and then integers. Integers represented by I or Z. It's represented by I or Z. It starts with negative infinity dot 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 up to 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Here you can see here 1 to positive infinity. This is nothing but your natural numbers. This is your natural numbers, also known as positive integers. Positive integers. While -1 to this is negative integers. Zero is neutral. That is neither positive nor negative. Okay, so if you represent, check the number line from 0 to plus infinity here. All these are not negative, non-negative. They are not negative, so they are called non-negative numbers. Non-negative numbers. So in short, if I say non-negative number, it means whole number. Instead of whole number, I can say non-negative numbers. Okay, similarly, just look at the number line. Just look at the number line. See, if I take 0 to negative side of infinity, what this is? These are not positive, right? Not positive. So they are known as non-positive integers. Non-positive integers. Okay, all negative integers are known as negative integer plus 0. Negative integers union 0. These are known as non-negative. Non-negative. Negative integers union singleton 0. This 0. Zeros from 0 to negative infinity, we call it non-positive. Here simply we can write 0, 1, 2, 3 up to infinity. Non-negative, here you can check. Non-negative means from 0 to this side. This is non-negative. And non-positive, these are positive. Similarly, from 0 to this infinity, this is non-positive. It includes negative union 0. Next is rational numbers. Rational number in lower classes up to 8, we define rational number as p by q, where pq belongs to integers and q does not equal to 0, and gcd or ICF of pq equal to 1, right? But if we consider decimal numbers, rational numbers are defined as after decimal if digits are terminating. Then we call that number as rational numbers. Rational numbers represented by Q. We call this as rational numbers. After decimal, if the digits are terminating, then we call it as rational numbers. And after decimal, if digits are non-terminating but repeating or recurring. Non-terminating but repeating, then we call it as rational numbers. Example: 5.75890. Here it is terminating, right? Fixed, we can count this, right? This is called terminating decimal. So this number is a rational numbers. And if we say 5.1111, so on, it never ends, but these numbers are repeating, right? Repeating or recurring. This is also rational numbers. It can be of the pattern as 3.123, 123, 123, repeating. This is also recurring. This is rational numbers. In P by Q form, example can be written as 3 by 2, 5 by 7, 8 by 9, 22 by 7. All these are rational number. Even 0 is a rational number because 0 can be written as 0 by 1. 1 is also a rational number. It can be written as 1 upon 1. Right. Next, let's study about irrational numbers. Irrational number is represented by Q prime or QC. In some books, you can see Q with C, and in some book you can see Q prime. Point number 1: irrational numbers. Those are not rationals. Number which are not rationals are called as irrational numbers. Point number 2: cannot be represented in P by Q form. As in integer, as in rational numbers. We cannot represent irrational number in P by Q form. We cannot equate them to Q by form. If any rational number is given, if rational number, we can represent it as P by Q form, right? But irrational number we cannot represent in P by Q form. Point number 3. Here also decimals. In decimal numbers, how do we define irrationals? In decimal numbers, if non-terminating, non-repeating, NTNR. Non-terminating. If after decimal the digits never ends, that is known as non-terminating. Non-terminating and non-repeating. Repeating or recurring. Recurring is nothing but repeating only. Example 3.1234, so and so. There is no repetition of any digit, right? This is irrational. It is nothing but non-terminating, non-repeating. This is very important. Special irrational numbers. Special irrational numbers. First is pi. N E. Euler's exponent. No, sorry. Euler is Euler's number. EULERS. Euler's number. Pi, you know, right? Pi, which is approximate to 22/7. Remember that pi is not equal to 22/7. We take 22/7 as pi for easy calculation, to make our calculation easier. Okay, but in reality, pi is not equal to 22/7. 22/7 is rational, but pi is irrational. Here, this tree, remember this tree, by heart. This tree, we are going to use them in calculation. This 4, pi equal to 3.14, approximation number of pi is 3.14, pi by 2 is 1.57, pi square is 9.86. Remember this tree, these three pi's. And Euler number is approximate to 2.714. Very important number, this tree. Calculation, in calculation we are going to use them again and again, so remember them. Here, write down a note. Any prime number given any prime number, if you take square root of that prime, then it becomes an irrational number. Any given prime, if you take square root, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 prime number. If you take square root of that numbers, then they become irrational numbers. Remember this. If anyone asks you, prime number greater than 22, prime number greater than 22, irrational number greater than 22, less than 30, you can say 23 root over 23, 23, right? Not remember, just remember this statement. Root over any prime is an irrational number. Some important terminologies. Let us check some important terminologies. Number 1, even numbers. What are even numbers? Even numbers or integers. Integers divisible by 2. Any integers that can be divided by 2 is even number. Right, example, so we can represent like this: -8, -6, -4, -2, 0, 2, 4, 6, 8, so on. These are set of even numbers. And -2 to left side, if you go left side, these are negative even numbers. And 2 to right side, we call it as positive even numbers. positive even integers. Yes, we are saying better say integers. Integers. Here 0. 0 is not, no sign. 0 has no sign. It is neither positive nor negative. And this 0 up to class 12, we are going to consider it as even number up to class 12, but in higher, not in higher algebra. Higher mathematics in algebra, we are not going to, 0 is not even. Just remember this. But up to class 12, we are going to consider if you say 0, 0 is even. Okay. But when you go for further research in higher algebra, 0 will not be, 0 is disputed. Some people consider it as even, some not. Next is odd number. After even, it is obvious odd number. What are odd numbers? Odd integers. Let's say no odd integers. Odd integers. How do you represent odd integers? We represent odd integer as 2n plus 1 or 2n minus 1. 2n plus 1 when n belongs to natural numbers. 2n minus 1 when n belongs to, when this also n belongs to natural number or z. If we consider only natural number, then we will say 2n plus 1. Here, let's see. 0, 1, 3, 5. These are odd. Positives. Positive odd. These are non-negative odds. -1, -3, -5. So these are negative odds. Next, prime numbers. What are prime numbers? Prime numbers define on natural numbers. Prime numbers are natural numbers. Remember this. First of all, prime numbers are defined over natural numbers. Okay. So definition would be natural numbers having only two factors. Factors is divisor. Factor means divisor. Only two factors, that is 1 and itself. 1 and itself. Example 2. How many factor 2 has? 1 and 2 itself. 3. It has only 1 and 3. 5. 1 and 5. 7. 1 and 7. 11. 1 and 11, etc. Only two factors. See, only two factors. Numbers, natural numbers. When you say prime, you will say natural numbers. Natural numbers having only two factors are called prime numbers. Point number 3. 2 is the smallest and only even prime number. Remember this. It is the smallest as well as the only even prime numbers. All other prime numbers are odds. Except 2, all prime numbers are odds. Point number 4. And remember that this is important. All prime numbers greater than or equal to 5. जो भी prime number 5 या 5 से बड़ा है can be represented as 6k plus or minus 1. If you give any prime number, let's say example 11, we can represent this in the form of 6k plus minus 1. 6 into 2, 2 here is the k, plus minus 1. So here we will use minus, not plus here. 6 into 2 minus 1 equal to 11. So 11 can be represented as 6k minus 1. Right, 5. Let's take another example, 5. 5 can be represented as 6 into 1 minus 1. 3. 3 is less than 5, so we cannot represent it in the form of 6k plus minus 1. Here we have said that all prime numbers greater than 5 or equal to 5 can be represented as 6k plus 1. So any prime number greater than 5 can be represented by this formula, 6k plus minus 1. Remember this is important. This point is important. Next point, last point of prime numbers. We said that every prime number greater than or equal to 5 or greater than 5 can be represented by 6k plus minus 1. But every number of the form 6k plus minus 1 is not prime. Okay, we say that every prime number can be represented by 6k plus minus 1, but every number of the form 6k plus minus 1 is not prime. Example, let's take example here. 35 equal to 6 into 1, 6 into 6 minus 1 equal to 35, right? 36 minus 1, 35. But is 35 a prime? Not a prime. Okay, got this difference. These two difference. Remember this two is important. Okay, let's go to next. Composite numbers. What are composite numbers? Composite numbers also define over natural numbers only. We will not say composite integers, composite whole numbers, composite real numbers. We will say composite natural numbers only. So natural numbers greater than 1 से बड़ा natural numbers and having at least 3 factors. At least 3 factor means 3 or more factors. Any natural number having at least 3 factors, that means 3 or more factors. Factor means divisor, are called as composite numbers. Point number 2. So 4 is the smallest composite number. Remember this, 4 is the smallest composite number. And point number 3, the smallest composite number is a multiple of 2, that is even. Remember this. Next, I think we don't have to spend too much time on this. We have done this in lower classes, right? So we will wrap up quickly. Number 1, coprime. What are coprimes? Any two natural numbers. We already defined that prime is a natural number, right? So when we say coprime, we will not say integers. We will say only natural numbers. There will be any two natural numbers having GCD or HCF, highest common factor, or greatest common divisor. Greatest common divisor or highest common factor equal to 1. If any two natural numbers are given and they are HCF, we'll say XY. XY belongs to natural number, and if GCD of XY is equal to 1, then we say that X and Y are coprimes. Okay. Or point number 2, for all A, B, we can write in mathematical form, belongs to natural numbers if GCD of AB equal to 1, then A and B are coprimes. Point number 3, examples. Let's 4, 5. GCD of 4, 5 equal to 1. So they are coprimes. 2, 3. GCD of 2 and 3 equal to 1. So they are coprimes. 4, 7. GCD of 4 and 7 equal to 1. So they are coprimes. Point number 4. This is important. Coprimes need not be coprime need not be primes. Need not be prime numbers. They can be prime number or non-prime number. Example, 7 and 9. If you take HCF of GCD of 7 and 9, you will get 1. So 7 and 9 are coprimes. But 9 is not a prime, right? 9 is not a prime. So co-primes can be prime numbers or non-prime numbers. Remember this, co-primes need not be prime numbers. And one important point is number 5. All consecutive natural numbers. Consecutive means adjacent. Adjacent natural numbers are co-primes. If you take any two consecutive natural number, 1, 2, they are co-prime. 2, 3, they are co-prime. 3, 4, they are co-prime. 5, 6, they are co-prime. Because their HCF will be 1 always. Next, twin primes. Number 1, write down number 1. Twin primes are always prime. Here we said twin primes. The word prime itself is there, right? Twins. 2 primes, twins. That must be twins. 2 primes having a difference of 2. 2 primes having a difference of 2. For example, 5, 3. 5 minus 3 equal to 2. Or 3 minus 5. Modulus will be here, okay? Always positive. These are two primes having a difference of 2 are called twin primes. Point number 2, if P1 and P2 be any 2 primes, then P1 and P2 are twin primes. If P1 minus P2, P2 minus P1 equal to 2. If their difference is 2, then we call those 2 prime as twin primes. In co-prime, any 2 natural numbers. Any 2 natural numbers. In twin prime, 2 prime numbers. 2 primes. Example, 3, 5, 5, 7, 11, 13, 17, 19. Next, let's start real numbers. As I had already said earlier, real numbers is nothing but rational numbers and irrational numbers together form the real number. That is here, Q union Q prime, rational union irrational. An important point here, rational number is nothing but our complete x-axis. That is this x-axis. Complete x-axis is real number. See here in the number line system, this complete x-axis, this is nothing but x-axis. You can see natural numbers, you can see negative integers, positive integers, and in between you can see root 2. After 1 and before 2 you can see root 2, root 3, e here 2. E value I told you to remember 2.714. Pi approximate value 3.14. Here 3 is here, and in between 3 and 4 we have pi, and there are infinite numbers between any two real numbers. Here in negative side also minus root 2, minus root 3. Here to root 2, root 3, e, pi. Here minus root 2, minus root 3, minus e, minus pi. So real numbers. For today, let's end here. We'll continue from real number in the next class.